All right, on this next topic, we're going to talk about the second derivative. And the second derivative is going to help us with something called concavity and also points of inflection. So looking at both of these graphs, you should notice that in both cases, the function f is increasing. Right? Think about the amount of money in your bank account. In both cases, it's going up. However, in the first case, f curves down, and in the second case, f curves up. What would we call this? We would call this actually concave down. Right? It looks like it's a cup that's facing down. Versus this is a concave up. Think of it as a cup that is curving up. Okay. Now, how does this relate to the second derivative? Well, take a look at the first example. Do you see how this first one represents the tangent line? And the second line is another tangent line. But what is happening to the slope of the tangent line? Well, it's actually decreasing in slope, right? This could be right here. This is a slope of maybe 5, but this one's a slope of maybe just 1/2. And how about this one over here? Well, this one looks like it's a slope of 1/2. But this one looks like it's a slope of, say, something like 5 or 4 or a bigger number. So in other words, the slope of your tangent lines are increasing. So you can see here that the function is increasing, but the derivative is decreasing, meaning the slope of my tangent line is going from 5 to 1/2, meaning the derivative is going down. So we would say that the slope of our derivative is negative because it's decreasing, and that's why we would say that f double prime of x is less than 0. Same thing is true here. We have our function that is increasing, and our f prime of x, though, is going from a slope of 1/2, and it's increasing to tangent line slopes of 5. So our derivative is increasing, which means our second derivative is positive. If that really confuses you, don't worry too much at all. All you have to do is memorize this. Okay, f is concave up if the second derivative is positive. And that is easy to remember, correct, because of the word up, and that's usually positive. We've got concave down if the second derivative is negative. You can think of negative as being down, right? Concave up looks like this, and concave down looks like that. Again, remember, think of a cup that is upright. Think of a cup, right? That's upright versus a cup that is downright. I'm a really good artist. Okay, so concave up looks like that, concave down looks like that. Okay, what is an inflection point? It is a point on a graph of f at which f is continuous and the concavity changes. So right there is your point of inflection. You can see here that it went from concave down to concave up. So that's your point of inflection. Same thing here, we're going from concave up to concave down. This one's going from concave down, and then all of a sudden it switches to concave up. Where do those points happen? Well, they happen when your second derivative is equal to 0 or your second derivative is undefined. You also need to, just like the first derivative test, the second derivative test makes you check f double prime of x, and if you have a changed sign from left to right, then you have found an inflection point. And this will make more sense once we do an actual problem. All right, so we're going to find all inflection points and intervals of concavity. If you see the phrase inflection points and concavity, this is the second derivative test. The second derivative test finds inflection points and concavity. So let's do this. F prime of x is going to be equal to 3x squared minus 12x. The second derivative is equal to a 6x minus 12. Now, we're trying to find inflection points, and to do that, we take our second derivative and we set it equal to 0. I'm going to add 12 to both sides. Drop down the 6x, divide by 6, and we get x equals 2. Now, is that an inflection point? Well, guess what? I don't know yet. We have to do our second derivative test, where I'm going to write an f double prime of x. We've got our -1. We've got our 2, that came from right here, and we've got our 6.5. Okay, now I'm going to choose an x value, okay, that is going to be in between -1 and 2. Let's go ahead and choose 0. Now I need to choose a value in between 2 and 6.5. Let's go with 3. Where do I plug that into? I plug that into the second derivative. As a reminder, my second derivative I found to be 6x minus 12. Right here, 6x minus 12. So let's go ahead and plug 0 into our second derivative. That becomes 6 times 0 minus 12. So we get f double prime of x is equal to a -12. Okay, what about f double prime of x when x is 3? Well, plugging 3 in, we get 18 minus 12, which is 6. Okay. So what are our signs here of our second derivative? Well, here we have equal to -12, so we have a negative. And here we have a +6, so we have positive. So this is an indicator of concave down because of the negative. And then this one's an indicator of concave up. All right. So we have learned several things. The first is we've learned our intervals of concavity. So we are concave down from -1 to 2, from here to here. And that's because our second derivative is negative. We are concave up from 2 to 6.5, and that's because we are positive in between there. So that's going to be from 2 to 6.5. Now, do we have a point of inflection? Well, we absolutely do, because it's gone from negative to a positive, meaning it's gone from concave down to concave up. So our point of inflection is at 2 comma. Where do I get this y value right here? Well, this is a coordinate versus these are intervals. So I'm going to take this 2 and plug it into my original equation. So that's going to give me 2 cubed, and then minus 6 times 2 squared, and then plus 1, and that gives me a -15. So that is my point of inflection. And I have found all 3 things that I was supposed to find. Perfect. Let's do another one. Find all inflection points and all intervals of concavity. Again, as soon as you hear that, you should be thinking to yourself, second derivative. So let's find the first derivative first. So derivative of the first is 1 times the second, plus the derivative of the second, which is e to the x, times the first. Second derivative, okay, well 1 e to the x is just e to the x. So this is just going to be e to the x is the derivative of that. And now I need to do product rule with this first and the second. So derivative of the first is e to the x times the second, plus the derivative of the second, which is 1, times the first, which is e to the x. All right, let's go ahead and let's pull out an e to the x. Okay, well, pulling out an e to the x will give me a 1 plus x plus 1. You can think of this as a 1 right here. So 1 and the 1 come from there, and then you've got your extra x there. Okay, let's simplify that. This is going to be e to the x and then x plus 2. All right, when is this equation equal to 0 or undefined? Well, this will never be 0 And so the only option is at x equals -2. So we have a possible point of inflection at -2 because the second derivative is equal to 0 at -2. So let's go ahead and we're going to have our -3 here. Okay, then we're going to have our 1 here. And it doesn't matter if you put your numbers on the top or the bottom. Okay, so there we go. So now let's go ahead and let us plug in x equals, let's say, -2.5. And here we'll go with x equals 0. Remember, we're plugging into the second derivative. So we're plugging into this right here. Let me get my answers for you. All right, when I plug in -2.5 into the second derivative, I get a -0.04. And that means that I have a negative second derivative in this interval. Over here, though, when I plug in 0 into the second derivative, I get 2, which is a positive number in that interval. So this is implying concave down, and then this one is implying concave up. Because there is a change from minus to plus, it could have been plus to minus. As long as there's a change, you do have a point of inflection. So our point of inflection is going to be at -2. How do we find this y value? Well, this is a coordinate, so we're going to take that -2 and we're going to plug it into our original right here. So that's going to give me -2 times e to the -2. And that value is a -0.27. Okay, so that's my point of inflection. My interval of concave down, don't confuse this with the point, this is an interval. This is going to be from -3 to -2. And my concave up is going to be from a -2 to a 1 because we're positive right here. Got a little aggressive there. Okay. All right, that's it, folks. As a summary, take the second derivative, and then if you have a negative in that, that means that it's concave down. If you have a positive, that's concave up. You're going to say your second derivative equal to 0. That finds you this point, which could be a point of inflection if it changes signs. Thanks for watching.